presentation will be given by Alan Fish, who has a long career in business rules and decision management. And Alan always has a very strong interest in human factors. And he also well-known author of book Knowledge Automation that most of us read, and it's really gave birth to decision requirements diagrams now implemented everywhere in DMN and in different decision modelers. And Alan also is deeply involved in use and advance of the FICO decision manager. And today his presentation also related to latest advances, but from human point of view. Alan, take over.
Thank you, Jacob. Okay. So I think a lot of us will have seen this diagram before. It's in the introduction to the DMN standard. I drew it, and I wish I had $1 for every time I've seen it reproduced in other places. But it shows the 3 levels of modeling which are commonly used in BPM Plus and actually in other ways of modeling as well. Essentially, we have orchestration models, and especially business process models modeled in BPMN. We have a level that describes the structure of decision making in the decision requirements level of DMN. And we have decision logic, which is maybe expressed in feel or as other sorts of functionals, which is encapsulated in the decision model as a BKM. So these 3 levels of model put together are a composition in computational terms. It's typically a hierarchy where you've got an orchestration calling one or more decision services, which each call a number of functionals. Now, in the word solution is often used, but it's an overloaded term. So throughout this talk, I'm going to talk about use case compositions. And by that, I mean a composition of models which actually carries out some required business behavior. And I say behavior very deliberately. All the components of a use case composition are executable models. In other words, they have a behavioral semantics, and their job is to model the behavior of a business, in particular its decision-making behavior. That is the behavior which is expressed when those models are executed. So looking at that last bullet point there, I really want us to focus on the fact that these are not convenient ways of drawing relationships between bits of code. Well, they are, but that's not primarily what they are. What they are models of business behavior, business decision-making behavior. And when a user constructs or changes one of these models, they are not expressing or changing code in their heads. They are changing the way they want their business to behave. And that's the viewpoint from which I'm taking this talk. So BPMN Plus models are very successful at capturing the what and the how of decision making. These 3 levels separate concerns very well. You've got the sequential procedural aspect of business processes captured in the top layer. You've got the dependencies of the decisions in the second, and you've got the detailed logic in the third. They result in models which are composable and executable and business friendly. It provides a very simple way of integrating ML models with other types of decision logic. And it provides a level of transparency and explainability of decision making. So what's missing? In my mind, what's missing is that these models don't capture the why. They don't say what the business motivation is for this business behavior. Decisions are, in a sense, agnostic as to their outcomes. A decision has a result, but it has no idea whether that result is a good result or a bad result. We can, in a lot of systems, we can set up KPIs and we can measure them, but the KPIs in themselves don't express value. It's just a number, and you don't know what, anything about the meaning of that number, at least not in the decision model. So I think we need a mechanism for embedding human values in our decision models. So these human values would typically be business goals. That's probably where businesses will first look for the expression of human value, but it's not just that. We'll also have, over the next couple of decades, I think, a rapidly increasing focus on environmental, societal and governance goals. I think companies are going to be required to demonstrate that they are addressing these things in their solutions. So I'm looking for a way to express human values that drive the specification of our models in the models themselves. These are my objectives. I want to embed human values in the compositions. I want to close the loop on decisions so that decisions are in some sense aware of whether they're working or not. I want to be able to help users by actually proposing improvements to their models based on their expressions of the value, the human values underlying their model. I want whatever approach we take to motivation to be transparent and explainable, just like the decision logic is. And I want all this stuff to be accessible to business users. I don't want it to be overly technical. And finally, I want all of the assets, all of these things to be able to be held as assets in an asset management system, so that they can be shareable. In other words, that we can distribute them, we can reuse structures which express human value. Now, there are already some existing standards for modeling business motivation. There's business motivation model from the OMG. There's the business architecture model from the Business Architecture Guild. And there's a sort of a subset of that, which was adopted by OMG as a business architecture core model. And there's Archimate from the Open Group, and there are probably others. But I had issues with all of these, and I want to be clear, I'm not making a judgment about these standards in their own right, but I'm assessing how appropriate they were for what I wanted to do. And for these purposes, I found the OMG BMMM too abstract, and it is specifically focused on the business rules approach rather than having any clear way of attaching to decisions and processes and so on. The other three, BA Guild and the Archimate standards, I found very, very complex. And to be honest, they really address business architecture rather than behavior. If you want to think about restructuring your business organization and your value chain to get more value out of a company, then they're bees knees. But for what we're talking about here, which is very specifically attaching human values to a decision model, they don't really fit the bill. Archimate came closest, I thought. It does have some useful concepts for business motivation, but I found it unwieldy. I might look at ways of mapping to it in future. So for now, I'm just going to focus on the specific concepts that I think are required, and we'll talk about that as a model. This is what I'm calling the business intervention model. And these are the presets on which it's built. Firstly, changes to models are business interventions. I mentioned this before when I was talking about the fact that models represent behavior. So when a user changes a model, what they're doing is intervening in the way their business is to run. They're not just making code changes, they are deliberately changing the way their business is managed. And typically, I know in this forum we tend to focus on the authoring of models for producing solutions, but actually most of the lifetime of a solution is to do with the management of that system day on day. And business users gradually improve the performance of their systems through successive incremental interventions. And they do it in order to achieve their business goals. Every intervention they make has an explicit target. They don't just make random changes, they make a change for a specific purpose. And often that is, so there's a specific reason in the user's mind for every intervention they take. And those often have numeric goals. They want to increase a certain aspect of their business by a certain percentage, for example. So these targets are defined using metrics. We measure business performance using metrics. You think of the high-level ones as KPIs. And any targets for an intervention are defined against those performance metrics. We can then monitor the performance of the modeled system against those targets and check it against the metrics. And finally, we can close the loop, as I talked about with the decisions, by feedback of the results of comparing the performance of the system with the targets that the user has defined. So those are the precepts on which I'm building this structure of concepts. These are the concepts I use. I'm not going to go through them all in detail on this slide, but a bit of expectation management here. The first task in creating any model framework is to decide which concepts need to be reified, which ones will form the objects in your database and your modeling tool. And you'll see that essentially what I've done here is to show you this set of concepts and the relationships between them. So that this concept model provides the classes and the principal relationships for an ontology. I have actually built the bones of an ontology to support this. And this is what will form the basis for the conceptual design of the user interface. So I'm sharing that here because I believe that how we represent human values in our systems shouldn't be a proprietary issue. And I'll welcome any feedback you've got on these ideas. So going back to our layered approach to modeling, I'm defining a use case composition as a composition of orchestration models, decision models, and decision functionals. So you can see there my use case composition contains relationship to those three types of asset. Use case composition may also be exposed as a service, which can be called by other orchestration models. So we have a recursive possibility here. From now on, I'm only going to talk about the use case composition as a whole, rather than the underlying components. So let's think about performance. The user's objective is always to maintain or improve some aspect of business performance. So I have a concept of a performance measurement here. The performance measurement records the performance of a use case composition in a scenario. So a scenario is a data set which records the execution of the solution in a certain world over a certain time period. It's usually a time series. It might be real or it might be simulated. But the point is that the measurement is very specifically a measurement of a particular composition in a particular scenario. The performance metric defines how that measurement is made from the data. We can call high-level metrics KPIs. We can call low-level metrics features. There are a few words being used in the field. I'm not going to distinguish between them here. I'm just going to call them all performance metrics. Do note, though, that I'm separating the metric from the measurement, and you'll see why. So the performance metric may, as I said, address business values or ESG goals, and it may be some utility function that actually combines a number of other performance metrics. So we can imagine a hierarchical tree of metrics. An intervention is a modification to a use case composition. It takes a pre-intervention use case and it creates a post-intervention use case. So you'll see here we've got two versions of this Y-shaped structure of performance measurement, one on the pre-intervention side and one on the post-intervention side. And the intervention has one or more performance targets, which are desired values of the performance of the post-intervention composition, as measured by the stated metric. You'll notice that the performance measurement, the pre-intervention performance measurement, the post-intervention performance measurement, and the target are all expressed using the same performance metric. The complexity of an intervention can vary very widely. It might be a single simple change, like the change in a parameter embedded in a rule, or it might be an initiative involving the coordinated behavior of a number of people in a project team. And if the intervention is complex, the performance targets may act as the goals of the initiative, and we might have targets delegated to particular team members. I've been working on other concepts to support those sorts of issues, but I'm not covering them here. Now, you notice that the pre-intervention and post-intervention areas there are just different instances of the same concept, so I can simplify this diagram just by folding them together. So we have our intervention, so the relationship, I'm basically cheating by drawing two relationships as one there between the intervention and the use case composition and performance measurement. What I have in mind is that the intervention would be associated with the deployment of a new controlled version of the decision solution. Okay, so now we've defined our performance targets for our compositions, we can monitor them. So I've got a thing here called a performance monitor. What it does is it checks the performance measurement against the criteria which the user has defined in the performance target. Simple as that. And if it finds that any of those criteria have been violated, it triggers a performance notification. The exact effect of that notification would vary from use case to use case, but the important thing is it results in the user being notified of the event, because the performance notification is an event. The user can then respond as they see fit, typically by making another intervention. This is when it gets interesting. The system can now look at the performance notification and the use case composition, and it can generate a proposal of some sort of intervention which would result in the performance of the composition returning to within the targets set by the user. So the system can make that can suggest that proposed intervention, and the user can decide whether to accept it or not. However, we need, as the designers and users of the system, to place some bounds on what sort of proposals are made. So I've got something here called a proposal scope, and essentially those proposals must be made within the scope defined in the proposal scope. So it'll be, for example, a subset of assets in the use case composition which it is allowed to change. They might restrict it to a particular decision, for example, or a particular parameter even. We can make it as specific or as generic as we like. So that's the entirety of the business intervention model that I'm showing you today. To summarize again, we have use case composition, which is behaving whose behavior is being recorded in a scenario, and we have a performance measurement made of the performance of that use case composition based on a performance metric. An intervention is a change to a use case composition with a particular target. The performance of the composition against that target can be measured and monitored by a performance monitor, which raises notifications when the target is not being successfully reached. And then proposals can be made for additional interventions within the scope of the proposal scope, which will bring the system back into its target range. The context within which I'm thinking all this would happen. Here, I know I'm guilty of one of these diagrams where you just throw everything onto one page, but it makes it easy. This shows the operational context in which these concepts would work. So the blue strip here along the bottom is the operational system which is executing our use case composition. The sorts of things that typically happen in a decision management solution are that we have some customer data, usually partly provided by the customer and partly from other sources. We make some decisions based on those data. We have an interaction with the customer specific to the purposes of this composition, but it may be, for example, to make them an offer or to tell them about potential fraud or whatever it is that we're doing for them. We get the customer's response. And then the KPIs, the performance metrics of this composition are measured off the back of all that. So we can look at any feature of that process that we like, and we can measure performance against a set of metrics. The grey strip is a simulated system. So it's still a model of the same use case composition, but it is run entirely in the lab. So we have a scenario which may be historical captured data or maybe entirely invented data. We have exactly the same decision model, because the purpose of this is to model the behavior of the decision service we have deployed, although it may have small specific changes that we're trying out. When we run that, we get simulated decisions. Now, of course, we haven't got any real customers here. So what we do in our simulation is we predict the behavior of our customer, usually using decision impact models. So we have action effect models which essentially use historical data to decide how the customer would behave in this scenario. We get our predicted response and we measure our KPIs off that. So our simulation can also has performance measures which we can look at. Up here we have a block I called optimization, and often the way in which simulations are used is as a way of trying out lots of different cases. If we take optimization proper, where you're searching a space of possible solutions and finding the optimum one or the set of cases, there are various clever ways to cut corners, but essentially what's doing is you're generating a possible solution, you're simulating it, you're evaluating it, and you're cycling around to find the best possible solution. That whether optimization is carried out in one block by a specific optimization tool, or whether it's done by a person using some sort of optimization simulation scenario, it's the same basic process that's going on. What we get out of it is some new aspect of the strategy which is implemented by the decision model. So it might be just the best value for a parameter to achieve what we want, or it might be a complete new business knowledge model, maybe in the form of a strategy tree, which we can then deploy into our simulation and check for its behavior. Around about this diagram, I've got various types of intervention that can be made. We have the creation of new predictive models using analytic modeling. We can deploy those into the decision service. We can start from scratch and we can author a whole new use case. We have action effect modeling to improve the behavior of our decision impact model. We have two levels of authoring here. If we're exposing parameters from our decision model, we can simply tweak those, or we can actually author whole rule sets or various other types of decision logic. So that's the basic overall structure within which I see this working. So the gold things here are all to do with the process of putting human values into our solution.
Alan, may I ask you, while you're still on this interesting slide, it is probably implemented within CI/CD environment, or this is just theoretical schema?
Right, okay. I've tried to be as product agnostic as I could be, in line with the rules of this gathering. I must say, of course, it's much easier if you can run all of this on the same platform, but essentially you could use different types of tool to implement any parts of this. Okay, what I'd also like to point out is that I've talked about performance monitoring at the composition level. So we're looking at the overall behavior of the whole composition, but actually you could apply it also at lower levels in the hierarchy of the composition. So for example, model ops is about measuring the performance of analytic models, and data ops is about monitoring the efficiency of data structures and features. So we can imagine, if you like, a hierarchy of feedback loops from the top level where we're monitoring the behavior of the whole system down to monitoring the behavior of individual components of it. But just for fun, I wanted to look at the techno-political historical context as well. I'm going to take you back 70 years to the Macy Foundation conferences on cybernetics. So this picture comes from the last meeting, which was in 1953. This group of people were just astonishing. What a collection of geniuses we have here. We've got the Macy meetings were actually set up and run by Margaret Mead here and Gregory Bateson, who are anthropologists, but we also have in here both McCulloch and Pitts, who essentially invented the field of neural networks. We have Ross Ashby, a psychiatrist, but who invented the ideas of homeostasis and requisite variety. We have Claude Shannon, who set up the field of information theory. We have, well, actually, von Neumann isn't in the picture, but Julian Bigelow is, who designed some of the earliest programmable computers from von Neumann's design. So there's a huge bevy of very clever people here, and they're discussing the principles of the use of information feedback for control in machines and living systems. So they're interested in how the same principles might be operating in both of those domains. Many fields have their origins in this group, including control theory, information theory, robotics, neural networks, computer science, and eventually, of course, AI. But of course, they didn't agree on everything, and these fields went in different directions. So on the left here, I have Norbert Wiener, who actually coined the term cybernetics from the Greek Kubernetes, meaning steersman. Now, the word steersman or cybernetics invites different questions. Norbert Wiener's Norbert Wiener thought the question should be, how can an organism steer itself? And if you see in this picture, this device is called a moth. It's called a moth because it was attracted to light, and it would move around on the floor trying to find light sources. But of course, then he fitted these moths with light sources themselves, and they would go into these wonderful dances around each other. On the right, this is Stafford Beer, who is one of my heroes. The question he was interested in answering was, how can we as humans steer an organization? So this picture here, which I'm not going to enlarge or attempt to describe, is what he called a viable systems model, which was a way of dividing an organization into a hierarchy of composed systems where each system is trying to achieve the goals set it, and it has total freedom as to how it achieves those goals by delegating it to other subsystems and specifying the sub-goals for those subsystems. So Stafford Beer thought of it as a way of giving everybody in an organization the maximum possible autonomy, so they have objectives, but they're not told how to achieve them. Now, I would argue that artificial intelligence has largely inherited the goals of Norbert Wiener's attitude here. We think, well, at least the public discourse is in terms of not just artificial intelligence anymore as a discipline, but artificial intelligences as autonomous artificial agents that have their own needs and goals. And I think actually for most of the people in this conference, that's not what we're aiming at. What we're aiming at is a way of using AI technology to help businesses and their customers. And our goal in producing these intelligent systems is to embody human values. We have singularly failed to make this clear, I think. We really need to show that even as AI is deployed, humans will remain at the center of our decision making, and that our decision systems exist to serve human needs and values. And we can only achieve this if our decision systems are modeled in such a way that the values they embed are transparent and accessible. And that is the spirit in which I'm offering the business intervention model today. So, in a nutshell, I'm proposing that human values can be expressed and attached to our use case compositions using these four concepts which I've colored gold. They're golden concepts in this model. And they are the performance metric, where the value is how should performance be measured? Yeah. What are we actually measuring to describe our business value or our environmental, societal, and governance value? Then, what performance values measured in that way are desirable? A metric by itself is of no use at all. It gives you a number, but do you want that number to be as large as possible or as small as possible, or do you want it to remain within certain values? Do you want it to be stable? Is it okay if it moves around? Okay. So the performance target tells you what we actually are looking to achieve with our composition. Of course, there's the intervention itself, which is what changes do I want to make to my business behavior. And finally, the proposal scope, which is about what types of behavioral change are allowed to be proposed to the user. My I think these entities should be created alongside the composition, and they should provide its raison d'etre. They are an integral part of the solution. They are more than just metadata. They are expressing the purpose of the solution and how we think this is the solution should be monitored and judged over time. So any initiative to build or modify a composition should start by defining these values, and the composition should be monitored and maintained over time to be sure that they remain in line with those values. Right. Okay. As always, I try to avoid anything product specific in this presentation, but my role at FICO is to enable business users of the FICO platform, and just let you know we are working towards a business user environment where these things will apply, where the business user feels fundamentally that what they're doing is managing their business, not developing software, and where they feel fully in control of defining the human values that underpin the decision making carried out by their business. So that's it. I hope I've left some time for questions.
Yes, thank you, Alan. Thank you, Alan. As usual, very interesting and very complex questions and problems you raised. And you can look on the Q&A. Can you see it? You already got several comments and questions. First of all, from Jim Sinur.
Okay, I think of goal and constraint models. Yes, goal and constraint models are, they could be ways to express the performance target that I had there as a simple concept. There certainly has to be a set of goals and constraints defined as a way of specifying what the target is. And I'm not going to deny that there's already a lot of work in this area. So yes, there might be various ways of using existing formalisms there.
Jim, can you specify your question? Is it does it answer or not?
Yeah, I think what I was getting at is that several vendors have done goal models, and several vendors have inverted them to be constraints. Other vendors have done constraint models, and I was thinking that if you could apply those in certain ways, you could represent the human values. I view it as a way of controlling AI, so it doesn't get out of sorts, particularly in the constraint area, where you could put governance kinds of constraints on AI.
Yeah,
that was my thinking.
I think
you
you're
can
right.
read. You can read more of that thinking in my blog.
Thanks, Jim.
Okay. Next question. You can see a question from Denis, the last one. Have you explored value delivery modeling language from OMG?
Or the operational model. So sorry, Denis, can you explain what I'm not with your question here.
Oh, so the first one on the simulation, in your overall overarching diagram, it seemed like you were using a different model for the simulation than the operational model that you specifically call as a simulation model. And my argument would be that probably what you want is to stimulate the operational model with simulated data, synthetic data, but it's still the same model you use, because if you have two separate models, you have chance of divergence and incoherence between the two models, as simulation models tend to be more abstract normally than concrete models. So I was just trying to clarify if your point was, well, we should have a model that simulates the behavior as opposed to just stimulate the existing model from different inputs.
Yes, now you're right that the simulation model may be identical to the operational model. But quite often the purpose of simulation is to try out changes. So it's often similar but slightly different to the operational model, deliberately so. As long as we keep track of what those changes are, then it's fine.
Okay. And my last was just a comment was that I don't know if you've looked at the VDML, the value delivery modeling language from OMG. It's not as known as many other standards from the BMI, but it does share a lot of the goals that you have there.
Thank you.
Yeah, so in a different way, but towards the same goal.
Yeah. Okay, I'll look it up. Thank you.
Okay, any other questions? Because we have time, and Alan, with all your experience, you just right now discuss the human factors. I still want to get your opinion about what's going on right now with generative AI. And first two presentations, they bravely put themselves in position to criticize. And so one of the question what we will probably discuss tonight and tomorrow, it's dramatically changes general approach, because it's not clear what is what is our source now of knowledge. They need added documents, right? Great, so it's more specific. We have prompts, and we have to manage prompts. And Gary even mentioned that we can edit generated DMN code. Is it, and we always had this, doesn't matter what was a generator of executable decision model, but we never touched generated code. It was just executed. And the most critical question is what is source and how are we going to maintain source of this knowledge? It's knowledge representation. So what is, it's changing dramatically right now. Or
Yes.
What is your take?
Well, it would be if we used Gen AI to actually carry out our decision making. Yes.
Mm-hmm.
And I have serious reservations about doing that as the technology stands at the moment. What you have with the large language model is, as Denise says, you have a model which is large. There's a model of language, okay, and that language is not actually very precise. It's the reason these models need to be so large is in fact because language is a very complicated and strangely perverse system, human language. So where I think that the low-hanging fruit, as they say, for LLMs will be in interfacing with human speakers of language. And I can see all sorts of applications for that for example, in explanation and transparency, in handling requests from customers that we're not expecting and all that sort of stuff. So long as they're pinned to a reliable model of the composition they're dealing with, which of course, Tony talked about this with making requests specific to a document or something. It could just well be specific to a decision model. And we're looking into LLMs for those sorts of purposes. I think if you start moving into the area of using LLMs actually to make decisions, I think you'd find it very hard to get approval for this technology under any of the upcoming AI legislation, for example. So we need to be very careful where we put our feet with this.
Okay. Okay.
But I welcome Denis' feedback. He's got his hand up.
Okay. More questions?
I was actually going into getting back to your proposal and wanted to hear your idea. So you're taking what I would still call a model-driven approach to your feedback on what's going on, and interestingly, you're grounding the feedback loop on outcome data. Have you also considered maybe, so models generally are a definition of structure and behavior. it could be interesting also not just to monitor the outcome, but also maybe monitor the change, your intervention, how it affects the structure and the behavior of the model in a larger, broader sense. So we can start not only going and be data-driven, but also be behavioral and structural driven in the improvement. So, for example, I may want to reduce the complexity of the structure of the organization, not necessarily the performance number, or I may want to change how the organization behave as opposed to the performance. I don't care if my performance go down if we behave better. So I'm just thinking if that's something you consider.
Yes, yes. Well, there are a number of aspects of that which are really interesting. Some of them fall in the area of test validation rather than operation. So they're sort of not really shown in the loop that I've got there, because they would be part of deciding on what intervention to make. But I've lost my track now. Yes, so I can imagine we might use generative AI to suggest improvements to models, for example. That would be quite interesting, so long as they are suggestions which are approved and understood by human users first. And that's why you're right to point out that I'm still model driven. I think that's really important, that if we want to have our systems owned by and understood by humans, that they have to have a structure which is understandable by them. So the idea of producing opaque models automatically using LLMs and executing them, I think, is just horrific, to be frank.
Yeah, and I wasn't suggesting the use of LLM at all. Actually, what I was more so in the early days of BPM and orchestration and choreography, one of my big research interests was looking at how we can apply pattern and anti-pattern. So, for example, if you're looking in a process management context, there's one pattern that is you should unify task into a single task so that you have a multi-skilled person do the single job as opposed to two-person. Or you can do the opposite. You can take a single task and break it into two individual tasks that can be achieved by two specialized resources. So we have the pattern and anti-pattern that apply. And I think with the model-driven type of approach, and what you're suggesting, I like really much this, is that we can look at, okay, what are the different structural and organizational pattern and anti-pattern and how they apply. So not necessarily generated. LLM is a different topic. Here, the model-driven approach, I think, has a lot of benefit that we can exploit. And when I was referring to model structure and behavior, that's more what I was talking about, and how we can look at the structure of the model, look at different structural patterns and how that affects how business is carried out. Or on the other side, we'd like to carry out business in a different way, so the behavior we want to change and how that affects. And then we can go back and forth between the data of the outcomes with the structure and the behavior.
I think you're absolutely right, Denis. Okay. Absolutely right. And we can't evaluate alternative models unless we have something to evaluate them against.
Okay.
But, yes.
Gary Hallmark made a nice comment that there is a big distinction between making a model versus making the actual decision, right, Wendy? So
yes.
we will keep discussing this topic, but Ron brings us back to your presentation and about steering the organization versus steering ourselves. So do you see his comment? And Ron, you can add if you want to.
Oh, sorry.
Management at least thinks they steer the organization through policies. How do policies fit with the intervention model, if at all?
Well, it depends how those policies are expressed, doesn't it? And what I suppose I'm doing is providing hooks in our executable compositions, which are precisely measurable. So a policy can be high level, it can be broken down into a number of achievable goals, and those achievable goals would be represented as the targets for the composition. Ron, I think I'll come back on it.
Ron, unmute yourself.
Yeah. No, I was just pointing out that the relatability to management requires, addressing their sense of how they think they organize the organization, the business, and they do it through policies, which just have to be drilled down. But the measurements somehow ultimately have to come back to the higher level policies. So I was just wondering if you had taken that into account in the
policies is a very broad term, though, isn't it? I mean, a lot of corporate policy would, for example, be expressed as rules and executed as rules within the composition, and some of them are more strategic in nature. So I think we have already for a long while been addressing the first use of rules for expressing policies at the detailed level. But what we haven't really grasped, I think, well enough is how the details of that behavior are shaped by more strategic level goals and policies.
I also assume, Alan, that in your diagram, the proposal scope would be tightly managed according to policies. So what you consider,
yes, absolutely, yeah.
So in your structure there, and that's why I was relating to the notion of organizational structure and organizational behavior, because through that proposal scope, you could, with policies and regulation, define what changes are allowable to a proposal by constraining the proposal scope. So I think you're already addressing it there.
Yeah. Okay.
Okay. Thank you very much. Very interesting presentation as always. And let me stop this recording and